So how does the virtual part, the PC part, this code part, is actually able to boot Linux? I will try to give this small outline for the loading procedure as a start, as a good start. This could serve as a good starting point for somebody who is going to perform some projects of their own for JSLinux. So a good starting point would be actually to start with JSLinux JS. This is greatly simplified way to specially extracted and provided by Ballard to show how the virtual PC is actually arranged, how does it start, and you will find the initialization of PC object as a global variable, and it will have this load binary method, which basically enables to load binary strings, arrays in JavaScript terms. And these three binary files, three binary strings, are actually our Linux. The first one, Linux Booter, was designed and is available as open source. See the project site, ballard.org. Is basically a kind of basic input-output system. It's one of the reasons why Linux in JavaScript, in the way it's built by Ballard, takes so much less time that it boots really fast. Second file is actually the kernel itself. There are some conditions and some tricks how to build such a kernel, how to produce, how to modify it. Unfortunately, I don't have so much experience in embedded Linux. That's why I was very interested in this project, actually to renew my experience and I was unable to compile a more recent version of Linux and to run it. But I was able to modify and patch the existing one. Initially, the ones that Bert took to start working on his project. And the third binary string is actually the root file system. The one that is mounted and booted, and the one that is the most easiest to be extended. One can just locally mount it as a loopback device, so that one can copy some files on it, extend it, and so on. There are some restrictions, though, for in the kernel itself, so that but this is unfortunately a topic for another talk, how to extend, how to modify JSLinux, the inner part of the box of JSLinux. And so far what I can tell is actually the project itself called buildroot. It's a great package. If you're familiar with building Linux kernel, it uses the same approach. You just run, just work with a bunch of makefiles and follow the compilation process of a certain toolchain, so that eventually what is built using the headers and binary environment that is provided by the elements of the toolchain. BusyBox package is a very known package for embedded Linux people. It's a bunch of main binary distributions that are most often used at Linux. And while working on JSModem, I use the standard C++ runtimes. I didn't go for the version of Belarus compiler. So at that point, what I should be able to do, and this took some time to figure this out, I should be able to rebuild previously mentioned binary files to add PPP support to the kernel, and also to add a PPPD package as a part of user space program. To add the device, or actually before adding one, probably a very good tutorial that I would like to recommend is actually this JS Clipper driver developed by Fabrice Bellard, especially in a very simple manner, allowing to work inside the box with a file interface called dev.js Clipper. And on the document part, on JS part, there is a component with which you can actually work very, very easily, very nicely done, very nicely built, easy to learn, easy to follow. Of course, it will help a lot if one has experience of developing user space drivers and kernel space drivers for Linux as a platform. But it's not really a big deal if you're patient enough to read and to find respective tutorials and to follow them. So to add second step, to add the device, you should actually take PC instance of PC object and basically seeing it as a JavaScript class, extend it with the modem class. So, and the most important part for me to arrange communication with JS, with this part that communicates with the box, but does no traffic yet, doesn't work with WebSockets, was actually I was kind of cheating here. One of the shortcuts was actually to use existing driver, to take existing driver developed by Fabrice Bellard. It's an OR driver, and to hook it on second COM port with this input-output port and RQ. This is a standard one, the default one. And as soon as I was able to boot and to see that this driver would be recognized by the Linux kernel, this was a very important step actually to achieve it. It basically means that being able to communicate with an existing driver in the user space, in the kernel space. It means I don't need to develop a new driver. I can use a standard one to arrange communication, which also bought me some time. And what is most important, I got a callback in the form of JavaScript, which basically provides me the necessary bytes of network traffic. If one is about to follow the virtualization protocol of x86 architecture, he would definitely organize most part of his traffic through input-output ports. And there are respective calls to organize the callbacks, which are to be found in this CPU.js file. There's two functions. They will provide the mainstream communications. These two are able to register callbacks. And this would be your working functions. So the other function, a signaling function, would be another callback function that actually follows the protocol of communicating directly to the CPU. And in the case of word instance, this function should be used. It is used. It is a kind of device that will require to use IRQ.